Hello, we would like to introduce you now the Polyuniverse game and the PUSE methodology in mathematics education. Today's children stand in a new relationship to the world. They are citizens of the global village, living in the endless web of connections, interconnections, and intersections. As a result, the educational system as a whole, including the teaching profession and teacher education, is challenged. New questions require new answers. The system of expectations and compliances, where teachers and children used to be caught up in, is getting looser, and the student-teacher relationship in many cases turns into fruitful cooperation. Teachers aiming at successful collaborations search for new tools and methods everywhere in the world. The present publication, the PUSE educational methodology, which is based on a Polyuniverse skill development tool, presents one possible solution in this process. The Polyuniverse geometric skill development tool was invented by visual artist János Saxon-Szász. The novelty of the game lies in the scale shift symmetry of the basic shapes: circle, triangle, square, and in the color combination system attached to it. Although the tool consists of truly simple elements and attributes, basic shapes, basic colors, proportions, it is at the same time also extremely complex. Because by shifting proportions and changing color combinations and the relationships, the number of possible solutions becomes virtually endless. That is why the Polyuniverse is more than play, more than art, more than maths. It includes all. Synergy in education. The Erasmus PUSE Polyuniverse in School Education project was the first step taken to map how Polyuniverse's artistic scientific approach could enter the gates of mathematics education. Its necessity was proven by workshops held in dozens of countries, by the participation in math art conferences, and last but not least, by the research project of the Hungarian Academy of Sciences. Mathematics is one of the key competencies. The teaching of primary and secondary school mathematics as an abstract science, which involves traditional tools and methods, is outdated. Many have recognized how important it is to raise children's curiosity and motivation, to be interactive, and make use of experience-centered education. Imagination and discovery claim more space, while students need more encouragement in mathematical problem solving so that they can recognize connections, instead of submerging in the abstract world of numbers, between visual and tangible patterns, and find creative, playful solutions. Teaching to see, learning through sight. Erasmus PUSE's goal was to develop a geometric combinatorial educational method, primarily for mathematics education based on a visual system. The outcome of the project is an educational methodology and student workbook, published both in Hungarian and in English. Moreover, an interactive platform, an expandable online source of exercises. www.polyuniverse.com. The PUSE methodology book consists of 5 main thematic units: combinatorics, probability calculation; geometry, measurement; sets, logic; graphs, algorithm; complex, visuality, interdisciplinary. Polyuniverse workshops and conferences preceding the Erasmus research made it clear that Polyuniverse does raise the interest in a wide spectrum, from kindergarten to university, one might say. Based on this experience, the PUSE educational methodology and student workbook target 3 different age groups: primary school lower grades, upper grades, and high school students. Our goal was to compile exercises exercises, and exercise series which encourage further thinking and raise new questions, instead of closing all thoughts after the solution is found. The polyuniverse, rooted in a special artistic vision, does not only inspire mathematics, but also triggers interdisciplinarity. Without affecting either polyuniverse's artistic background or its physical characteristics, the use of the free online mathematical application called GeoGebra in the book expands the use of polyuniverse in mathematics. Going beyond educational aspects, the need arose to map connections between the tool and psychology, so we included a game research expert in the project as well. Measurement results show that polyuniverse effectively develops cognitive areas such as visual perception and related skills. There is also a traceable increase in attention capacity. Moreover, based on surveys and interviews with experts, the impact of the tool manifested in areas such as creativity, mathematical and logical thinking, or social skills. Using the tool in group work helps mapping in-group processes as well. In the course of observations, intentionally or not, participants' roles and quality of their cooperation became manifest. The PUSE methodological book doesn't claim completeness. In other words, it is not a closed collection of exercises. This couldn't have been its purpose. The polyuniverse, in fact, is not simply a tangible tool or a closed system puzzle, but an open math art system which models the universe, allowing a glimpse into its internal laws. This book is a beginning, just like Christopher Columbus's undertaking once was, who was first to cross the ocean to let others following his footsteps discover America. The PUSE methodology book opens up the way for teachers and students, artists and scientists. We can all enter into polyuniverse's spacious world, explore its complex realm, further discover its laws and regulations. While polyuniverse offers scale shift, the methodology based on the tool offers a change of attitude for today's educational system, not in order to achieve small, medium, or large bits of knowledge, but endless knowledge. Thank you for your attention.